Morning. Obviously everyone's looking into donuts already. I just wanted to introduce Gavin McLaughlin, right?
Yep. Good pronunciation.
Thank you.
That'll do.
Yeah, this is Breaking the Performance Bottleneck. It's about to start. Just hope everyone enjoys themselves. And I'll hand over to Gavin now.
Thank you.
Pop this down here for you.
Okay. Brilliant. So we've got enough technology. So thanks everyone for coming along. I don't want to do an out-and-out product pitch. So you guys are probably thinking, great, we're sitting in a sponsored session. It's going to be just XIO, XIO, XIO. What I'm going to do a little bit is talk about who the company are, because most of you in the room are probably thinking, who the hell are these guys? So I do a little about who the company are and where we come from. But what I'm going to talk a little bit about is actually a follow-on almost from the session that Ruben just did in the other room, which is what is the problem with storage, particularly in the VDI space, but actually in a lot of places where there's high random I/O bottlenecks, and talk a bit about that. I'm going to talk about how we see that problem manifesting itself, and then what are the options that are coming out in the marketplace. Because you've probably seen there's been a whole plethora of things like SolidState vendors and different technologies come to market where everyone's saying, we've solved the problem. And there are a number of different ways to attack this, ranging from Fusionio to some of the traditional storage vendors like EMC and HP, to us who are doing things kind of differently. So I'm going to walk through some of the options there are, a bit about the benefits of what we do, because we're paying a lot of money to be here, so I have to do a bit of a product pitch. But then I started to think about what would be a good use of the time, because these are actually quite long sessions, which is one of the reasons we gave you donuts, by the way, to keep you alive, is what would be a good use of time. And what I actually thought about is there's a lot of myths around in the storage industry that pretty much disk's a disk. And in fact, if any of you are in the storage bottlenecking performance that Ruben just gave in the other room, a lot of the slides talked about disk as just standard disk and what everybody gets from disk. And we do things a bit differently in XIO, and I'll explain why we do things differently. But then I asked Paul, who's our technical services manager, who's going to be presenting in a minute, to talk about why we're different. So that's going to go a little bit of depth in technology about how we lay data out on disk. Bear with it, it's only about 10 or 15 minutes long. Some of you will be thinking, wow, do I need to know this? But I think it's important to understand that not all disk vendors are the same, but also there's tricks you can use at the back end of storage infrastructure to solve the problem that's out there. So we'll do a little bit about that. So we won't keep it too long, and then we'll do Q&A at the end. I like to do Q&A as I'm going through because I get bored by PowerPoint as much as everybody else does. But I think with the format of the room, it'd be better with a handheld mic towards the end. So we'll try and have some time for Q&A. So, who are we? How many people have heard of XIO? Other than 2 customers that are in the room and the XIO staff. So not many people have heard of us. How many people have ever heard of a storage company called Xiotech? Okay, a few more. We are Xiotech. We rebranded. The reason we rebranded is the company kind of changed direction. So the change of direction is we bought in a product line from another company that became our core product, which was from a company called Seagate. How many people have heard of Seagate? Yeah, quite a few more. So Seagate was starting to put together their own arrays. The actual array was designed by the team who designed the HP EVA and a lot of the HP StorageWorks products, so you've probably all heard of them. These guys had been working for some years to design a storage array that didn't go wrong. And by that I mean that it avoided disks failing. Because as much as you might think, well, it doesn't matter if a disk fails, I can hot plug it. Those of you who have ever had a RAID rebuild, particularly on an EVA, will know that's quite painful, both in terms of performance and also risk. I always joke that whenever there's an engineer in a data center or a human in your data center, that is the biggest chance of error. I was a field engineer, I knocked cables out. I've seen people swap the wrong disk, I've seen silly things happen. So the whole idea of Seagate's array division was to design arrays that never got touched for 7 to 12 years. You don't swap out disks. You actually keep the disks alive and you use mechanisms to protect them in-house, and I'll talk about that in a minute. But what happened was that team got spun off because obviously it was in competition to some of Seagate's customers, got sold to Xiotech. Xiotech realized the strength of what we call the intelligent storage element product, and pretty much now XIO is based around the old Seagate product. So if you've heard of Seagate, that's us. Okay. We're actually, unlike a lot of people playing in this performance marketplace, we've been around a long time. So we've been around for 17 years. We've only been around 6 to 9 months as XIO. So it was a rebrand. The good news is that means there's about 7,000 implementations out there of our technology. So it's not like a lot of the startups that are appearing in this marketplace. We've got a lot of mature technology out there. There's actually customers of ours in the UK in the room today. What we are doing is doing a big push in Europe. So the reason we're here today is to talk about what we're doing across Europe. But really we're focused on 2 markets. One is VDI and one is relational databases. And you'll realise why as we go through the technology, why we focus on those 2. So some of you may have seen this slide before. Certainly if you went to one of my presentations at HP or Sun when I worked there, you probably even saw the same slide. And it's that there is a big gap. Those of you who designed storage backends or put together backend storage, particularly for VDI, will know that there is a huge problem. Courtesy of Moore's law, we've seen some fantastic growth in processors. The storage industry has kind of got away for many years without growing at the same pace. We haven't seen technology improve. And what that means is we get this big disconnect between storage and CPUs. Now, many people show this slide and show ways that they've solved that disconnect. But the truth is there is a problem out there. And it's got worse since we've seen the virtualization rise in the industry, both from virtual machines and from virtual servers and from application consolidation, where people are putting more and more into the storage. And there's been a whole rise in the industry of tricks and tips to just try and solve this, ranging from Atlantis, who are trying to turn random I/O into sequential, some of the solid-state vendors that are coming around. And actually, we've seen it get worse and worse and worse as people collapse estates together. And also the economy has been a big driver here. So it's no longer acceptable to design a system for 50% utilization. If you go to your CFO and say, I want technology that's going to have a 3-year write-off period, and I can never more than half fill it, he will probably start removing parts of your body, if you're lucky. Okay? It's not acceptable. You've got to get 100% utilization out of your technologies, and you've got to look at good, long 5 to 7 year write-off periods for technologies. It's not like the old days. We can't get away with it. And actually, it's worse in virtual platforms because we've got a whole bunch of random I/O, and sequential I/O coming through the system. So we're actually pushing it even more and more. And as I said, people are trying tricks down here to help with this randomness, but it's the randomness that causes problems. I've worked in storage for a frightening amount of time, designing a lot of back-end systems, and if someone sat down and said, right, I've got a large infrastructure, a very high IOP need, it's all completely random I/O and it's completely small block sizes. Usually for vendors I've worked for in the past, I will run out the door screaming because it's the sort of nightmare scenario that you don't want to see. XIO, I like to think, have solved a lot of these problems. So, what are ways to solve this random I/O problem? What are ways to solve the storage bottleneck? As I said, there's a number of different vendors coming to market. Option 1 is to stick with your existing disk technology. So your EMC, Symmetrics, your 3PAR, your NetApp box or whatever, and put some solid-state drives in it. So a lot of people are going around and touting that solid-state is the saviour of the universe. No problem, just stick a couple of solid-state drives in, you'll all be sorted. Life's not actually like that, and I don't know if there's anybody who's actually tried it. But you have the ability to put some solid-state drives in your existing SAN array. Usually you find it's limited, so they'll say you can only install 4 or 6 drives or something like that. It's usually for 2 reasons. One is the back-end bandwidth is just not capable of the throughput that's required of these. But most importantly, the controller can't handle it. So this is another thing you'll see in the solid-state marketplace, is that someone will sell you a drive that they claim can do 200,000 IOPS. And then in small print, what they don't tell you is that the controller side of it can only handle 50,000 IOPS. Brilliant, so you've just wasted it. It's like buying a high-performance car that you can only ever do 30 miles an hour from. You're never really going to get the benefit from it. And often, in this case, when you install those drives, you have to use some sort of tiering mechanism to take advantage of it. So you've got things like EMC Fast, Compellent are out there talking about this sort of stuff. Tricks to move stuff. But actually, usually based upon activity. So as a file is accessed, that file gets migrated over time into solid-state, into the fast storage. As it's then not used, it's moved back into the pool of cheap disk. It can work if you've got a nice predictable workflow. If you've got truly random I/O, it's no use to you because the time it takes to move the data back up to the tiers, your randomness has gone and you've just wasted it. So, and also there's a lot of complexity there, and more importantly, license costs. And that's one big thing across virtual infrastructures, whether it be at the software layer or the hardware layer, license costs are a problem, so that can hit you. And ultimately, what you get here is pretty much a high capex because the cost of those devices is quite high. You often get constrained on capacity because, as I said, you can only put a small amount in. And actually, ultimately, it's a high OpEx solution. Whether you move the data around or whether you're using some sort of tiering software, there is an overhead and a complexity to doing this. And that's option one. So high cost, constrained growth, risk. It's probably okay because you're working with your existing storage provider. You don't have to go through change. You don't have to retrain. So, I'm going to give a medium level on risk. I'm going to be polite. Option two, the Fusionio option. Let's be blunt about it. There's a couple of alternatives out there, but we all know this one's the Fusionio one. So cracking open your servers, adding a PCI card, closing it back up, and putting it in that way. And Fusionio have been talking about don't use SAN storage. They made a big campaign about it, which is always funny when we do a trade show and we're next to them, by the way, because we end up just bitching with each other. It works. I like the Fusionio cards. When you're looking at a single application, single host environment, particularly in SME, in the small, medium enterprises, it's good, it works. If you've got a single application, how many people run a single application? I'd like to think life would be easy if I could just have host, storage, one application. Brilliant, I can go home and I sleep easily at night. Doesn't like that. So that's why we've seen the rise of things like vMotion and all these tools to move around data. And you're constrained when you put your storage in your host. You really want shared storage if you're going to take advantage of flexing out your loads. And actually, they're expensive. So a lot of people say to us, I like the Fusionio cards, I just can't afford them. I like the idea of SLC, SolidState. And then, again, you've got the complexity of what goes on your Fusion cards and what goes on your traditional storage if you want capacity. How do you move stuff backwards and forwards? Do you do it manually? Do you use some tiering software with a high license cost? But you've got to decide how you do that. That adds risk and that adds complexity. So ultimately what you've got is pretty high capex, so it's going to cost you a lot of money to buy these cards. You're going to be constrained on capacity, again. But more importantly, you're going to be constraining functionality. And the thing I hear from people is we would like the ease of use of SAN shared storage, but at the price of commodity disk with the high performance. Like, well, don't we all want that? We think we're getting close to it. We're not at the price of commodity disk, but we've broken the back of some of this. Option three, the Violin, the Whiptail, the Nimbus, the Pure Storage, another one that's probably going to launch tomorrow, because especially with EMC buying Extreme IO, before they even launched a product, they paid $400 million for a company that hadn't even sold anything. This is nuts. It's a mad marketplace. So you're seeing every VC-backed solid-state vendor in the world coming to market. Violin probably making the biggest noise in Europe right now. These are the idea of taking some very expensive single-layer cell solid-state drives, racking them up, giving them a fibre channel interface, or in some cases iSCSI interface, and treating them like a standard storage array. Great. Outrageously expensive. Now, if you've got all the money in the world, if you guys have got an unlimited budget from the CFO and want the best, most performant storage there is out in the marketplace, go and buy one. Seriously. But how many people can afford $400,000 for a 10 terabyte storage array? You know, it gets kind of expensive out there, and they are good. In a lot of cases, you do have to take a hit for performance in that you trade it off to high availability. So the answer from a lot of these solid-state vendors is, we do high availability, buy two. Great, lovely. Again, how can you afford 2 times 400 grand in tools to do it? Company stability. A lot of these guys have just started up in the last year. You're buying into some technology, which, by the way, has arguments about warranty and life cycle. A lot of these come with 12 months warranty. You're buying in something that is going to be supported in 5 years' time, which is your write-off period that your CFO has told you you've got to have. So there's a lot of worry about that as where they could be going. As I said, they're expensive. And actually, you're limited by capacity. Because they're so expensive, you don't buy as much. So yeah, there are 10 terabyte systems out there, but you're going to pay for it. So actually, this is probably the worst profile one. And you've got the high cost, you've got a lot of risk involved, and you are constrained on growth in terms of capacity. What we found and what we've been playing in is a different market which is starting to emerge, and it's not just us, there are others starting to come to market in this space that see solid state as a tool rather than a solution. And that's how we see it. It helps you solve some of the performance problems, but it is this amazing panacea that's going to solve all world health problems out there. It's just something that we can use. So we see solid state as an enabler to solving the bottleneck. And what the hybrid idea of combining solid state and hard disks together is to get to the performance of solid state, but at a cost profile that's just slightly higher than the hard disk. So you're getting, for want of a better term, the best of both worlds. But the difference between this and what you may think of putting solid states into an enterprise system is the ability to move stuff backwards and forwards between solid state and hard disk seamlessly based upon I/O activity. So block level underneath the LUN that you never need know about is the ability to move data backwards and forwards based upon I/O activity. So it means that you can keep all your standard SAN business practices, all your tool sets, just treat it as standard switch fabric fiber channel, but not have the performance limitation. It just moves backwards and forwards. So what you actually get is balance. And again, those of you who have ever seen me present when I've worked for different vendors will know that I always use them, no matter how times I try and move away from these, I still find that customers buy storage based upon the balance of these three balls. And they'll change over time. You know, with the dot-com boom that we saw in the late 90s, early 2000s, everyone said, bugger the cost, I want growth. I don't care how much it costs. Which is why loads of people ran out and bought EMC Symmetrics at $1 million a pop. Life's not like that now. We tend to find more customers are worried about cost and risk than growth, but it changes around. And I'll always ask any of our sales guys, which one of these is the customer? I love that door. Which one of these is the customer basing their argument on? But this is where the market we're playing in is around hybrid. So, I am not going to go into the full-on product pitch, but I'm going to give you a couple of slides. How do we do that? So I'm going to pick out a couple of elements here. Apologies, by the way, for those guys at the back. This has been videoed, so you'll see it, and we can distribute the slides. But I'm going to pick out a couple of things. We actually have two layers of distinction. We have software differences in our product line, and we have hardware differences. By the way, we sell the storage as an appliance. The software is running on the storage array. This is not something that we run server-side. So we just treat it like a standard fiber channel. So some of the solid state vendors, by the way, it's one thing I should add, ask you to add a driver onto your hosts that just eat CPU. We don't have that. You just use your standard fiber channel driver. So your Emulex or your QLogic or whatever you want to use. We don't do anything crazy. Hardware distinction. Paul will cover this in a little bit in a minute, but we have an unusual feature, as I said, that we don't have hot plug drives. We have drives that are sealed in. The reason we do that is actually twofold. One, it gives us better reliability. We can cool the drives and stop them vibrating, which stops them going wrong a phenomenal amount of times. Okay? We run our own firmware on the drives. We don't take the standard Seagate firmware. The reason we do that is we're quite different in that we can actually remanufacture a drive in situ. So when you send a drive back to Seagate that's faulty, by the way, a lot of the time there's nothing wrong with it. It's just had an environmental issue. When they get it back, what they often do is low-level format it and relay out the tracks and rebuild all the servos on it. We can do that in situ. So we can take a drive offline, rebuild it, bring it back online. If there is a physical fault on that drive, we can just lock off one head. So why throw away the whole drive when only 10% of it has got a fault? We just work around that 10%. So there's a lot of hardware distinction that we do to design it, and I'll show you something that talks about vibration in a minute. But we also have things like active-active controllers, great intelligent cooling within the unit, a lot of hardware distinction that just is there to protect the system and to stop it from ever going wrong. We design our boxes, by the way, with a 7 to 12 year duty cycle. We've never been physically touched by anybody. We do not want an engineer in the data center popping drives, swapping out batteries to protect cache. So we use supercapacitors instead of batteries, for example, to do that. But these are all the sort of things that you need to do in order to protect yourself. The next layer around software distinction is threefold. One is the way we lay data out on disk is kind of different, and Paul's going to go into a little bit more depth about how we lay that data out. But there's two reasons for doing that. One is to get the most performance out of the disks. So disks are slower than solid state, hard disks are. But there's tricks you can do to make them a hell of a lot faster. But more importantly, a hell of a lot faster at 100% utilization. I won't name any names, but certain storage vendors, when you fill them past 70%, stop kind of working properly. And I had a customer recently who said, company N has been in to see them. They complained their performance had dramatically dropped. And the sales guy said, it's because you filled it above 70%. Do you want to buy another one? Go to your CFO with that argument, watch what happens. The truth is you've got to get 100% utilization. So we test our boxes, and I'll show you, Microsoft did some tests recently for us, where we fill them up to 100% capacity. But the real trick is this ability to move data between solid state and hard disk, which we call Continuous Adaptive Data Placement, or CADP. By the way, we are really bad at acronyms. We come up with acronyms that are just horrible. So CADP is very unusual in that it has the ability to move data between solid state and hard disk based upon I/O activity at the disk layer, or the block layer, I should say, underneath the disks. So working out where the hotspots are, moving it, and doing it in real time. And if you pop by the stand later on, we'll show you a video of that actually happening in real time, where data has been moved, and more importantly, moving it back again. Why waste your expensive stuff on something that doesn't need high I/O? And then a lot of things that are there to protect us, which is Cortex, which is around not just dial home, but sending back information to base about performance and about telemetry and how the box is running. And by the way, publishing all that through a RESTful API as well. So if you want to manipulate that data, or you want to manipulate the box, you can do it yourself. To the level of right now from this laptop, I could tell you what fan speed, what rotational speed the fans are blowing at in one of my customer systems anywhere in the world. It goes into an incredible amount of depth, which is useful stuff because it means we can keep learning about different environments. And these elements together get us to the point where we see that we have a much higher degree of performance for a fraction of the cost of the vendors out there. If we were to compare against some of the solid state array vendors that are out there at the moment, commonly we're about the same performance level for about a quarter of the price. And it's because we're using commodity components, such as SAS disks, very cleverly to get the performance up. And that also then helps in terms of TCO leadership, because we're lower power, we're lower operating costs. I'm not going to go into the whole TCO argument, there's a lot of elements there that we've got statistics, by the way, to back this up. This is not just marketing fluff. And the hardware itself is actually pretty simple. It's a 3-rack unit array. This is probably the most product pitch slide that I've got, by the way. We have this concept called data packs, which are a 20-disk pack, which are either all hard disk or a combination of solid and hard disk, solid state and hard disk, depending on the configuration. We have a huge amount of bandwidth. We have 64 gig of fiber channel off the back of the box, and we have some very clever designs. Little things that seem crazy that when you look through the back of one of our units, you actually see all the way through, and you see the surface of the drives. The power supplies are designed to draw the air through to keep the drives cool, to stop them going wrong. These data packs here have little grommets on them. The grommets are there to stop a drive moving. If a drive moves or exhibits any sort of vibration, it will affect latency. And if you've listened to any presentation on performance and VDI, or you've read any book on performance and VDI, it tells you that latency is probably the biggest killer for you. Yes, high IOP numbers are going to be a problem. Bandwidth quite commonly actually isn't a huge problem. It's normally about IOPS. But latency is the one thing that will really hit you. If your storage system has a 15 millisecond latency, it's going to work its way through the system, and by the time it hits your user, it's a freeze on their desktop. And freezes are the worst thing. You don't want that phone ringing. And we've had many customers, bring us in purely because they're getting freezes. So we pack these things into these like canister type things, and then you can add 1 or 2 of these to the system. So actually, from a 3-rack unit, you can get a usable figure of around 10 terabytes. So we can actually get quite dense storage and good capacity sizes into one of these units. And as I said, little things like supercapacitors at the front rather than batteries, because we've designed it with a 7 to 12 year duty cycle, which is the other thing on our hardware. We're very different. We give a 5-year warranty. I don't know anybody else in the storage industry that gives a 5-year warranty included in the price. The reason being, we're confident and we have enough of these out there that we know they just work. And commonly, you just will not see a field engineer because it will just keep running. As I said, we've designed it that we can fill the drives up to an incredible amount. to 100% and not have any problems in terms of performance. So, I had a customer recently say to me, yeah, but is noise in a data center really? Are you saying that if I make a lot of noise near my disk array, it will slow down? And the answer is, yes, it will. And a lot of people didn't believe me. So it reminded me of something that I used to work for Sun, who are now at Oracle. Oracle are downstairs. Is when they launched something called this S7000, which was a thing called Fishworks, some software, they took, I don't know if anybody of you used dtrace, which is a feature of Solaris, which is brilliant. dtrace is a fantastic piece of software. It shows you everything that's going on inside your box. One of the things it can show you is disk latency by individual disk. And the guys wanted to show off the software. So they put together a YouTube video, which I'm going to play, it's only a few minutes long, that actually shows the ability of it. But what it does show is completely that there is a problem in the marketplace with noise, bizarrely, in your data center. So just bear with me while I flip the mic over and just run this for a minute. In fact, actually, I'll cheat and use this one.
Hi, I'm Brendan. We're here in the Fishworks lab. Sorry for screaming, it's very
Can you hear that at the back?
The air conditioners and servers all around me. We just made an interesting discovery and we thought we'd show you straight away. So over here I'm measuring disk I/O operations broken down by latency. I've also drilled down to disk I/O operations taking at least 520 milliseconds broken down by disk. This is using dtrace so I can do performance analysis of disks. I'm applying a write workload to 2 JBODs, which are over here. The lights are blinking on these JBODs because they're doing work. What I'm going to do is not recommended. This is not supported. Do not try this at home. Ah!
I used to work with Brendan. He is insane, by the way. It's just, yeah.
This is not special effects, this is real. What we're looking at here is the effect of disk vibration. Vibration is a serious issue, and we can see the effect here that it's caused. So here, the latency for the disks that are under the workload has gone up. Here I can see which disks have now had I/O operations longer than 500 milliseconds, and I can find out that they belong to the JBODs I was just shouting at. So, amazing stuff. This has been made possible by analytics from Fishworks, which lets us look at things we've never seen before. Disk latency, high latency caused by vibration is a real issue. You've seen it. It does exist.
Just don't let Brendan shout at your discs.
That's right. Don't shout at your JBODs. They don't like it.
So, yeah, a bit of comedy. And I always thank Brendan for actually getting the point across that disk vibration is an issue. But this was a good example of the things that the guys at XIO have learned that affect it. So you may actually have weird performance problems. You may have a data center where every now and then performance drops, your users complain. You have no idea what caused it. It could actually be noise. It could be vibration that's happening in the data center. So actually our guys took that as a bit of a test. So when they were designing these canisters, or the latest version of these canisters, one of the things they did was design the grommets and then make a load of noise. Worked fine. They then went and got one of the shipping racks, the big metal ugly racks, put it in front of one of our arrays, monitored it, just like Brendan did, and threw the rack on the floor. Latency changed. Disk slowed down. So they redesigned the grommets, and the poor muggers had to stay in that lab for days, redesigning rubber grommets, that when they threw the rack over, nothing happened. We stayed predictable performance. And that's what it's all about, is providing sustained performance. There's different things that can affect it, and what we've been doing is changing our hardware design over the years and evolving it based upon things that happen in the real world. And it's a bit of a light-hearted take on it, but it does get the point across that not all disk vendors are the same. And in fact, you'd be amazed how many storage vendors use actually the same disk shelves in the back end. And Paul's going to talk a little bit about just things he saw when he started with the company, just about how we design things a bit differently. But that's from a hardware point of view. And as I said, from a software point of view, I can't emphasize enough, the important thing for us is this CADP software, this Continuous Adaptive Data Placement, which it's very, very quickly learning the environment and working out how we can move data backwards and forwards between solid state and hard disk, but in real time. So there's some great vendors out there who have some great tiering abilities, but some of them are extreme. Some of them do it once per day, is to move stuff backwards and forwards. How does that help a random I/O workload? You're going to end up with a whole data set in solid state before you can actually get any efficiency out of it. And by the way, because this works underneath, this can help VDI, this can help relational databases, this can help a lot of things. We did a lot of work with Microsoft recently where we sat underneath SQL Server, because in SQL Server it's a good example that you've probably got the 80-20 rule, is that only about 20% of that data needs the high performance. The rest of the 80% doesn't kind of need it. So we can just pull the stuff in as we need it, the individual blocks. And actually Microsoft did some tests for us. So this is quite a while ago with Microsoft, where they pulled us into their solution center. And they're quite evil buggers. They test storage vendors at 100% utilization and do nasty, nasty things. They run up 90 virtual machines, did a bunch of random SQL I/O, did a bunch of sequential SQL I/O at the same time, by the way. They started up some VMs, they teared down some VMs, and they kept repeating the same test over and over, and just doing it until they break a storage vendor. And what Microsoft said was the quote at the top. They couldn't believe that we were just smoothing out all the hotspots. And they said it was weird. We kept throwing stuff at it, and actually it just seemed to get faster. And it's because we're learning very quickly. We don't have this learning period that activity-based tiering does. We can sit in the background and give the high I/O. And as a result of this, Microsoft now buy our stuff. And actually on a reference call recently, one of the guys from Microsoft said, look, I've got to get the point across. I can get free storage from pretty much anyone. Everyone wants to give us free stuff because we'll talk about it. He said, but I actually buy stuff from XIO because I see value in it. And these guys have got over 1 petabyte of our stuff now because they see value in it. And that's the main thing. And actually we've been working behind the scenes with some software vendors, and I just wanted to use this as a good example. This is a telecom billing company, and anybody who's ever done anything in telecom billing will know it's a pretty nasty random I/O environment. And they actually designed a storage array to cope with a 30 million subscriber telecom billing system. The design they come up with was this: 5 racks of big disk arrays using what we call wide stripes. So striping data across lots of different disks to try and get performance up. 5 racks of equipment, rather a lot of fans on the top, as you probably noticed, putting out quite a lot of heat because they're all using 15K RPM drives, pulling 3-phase power, so nasty amounts of power, in order to deliver it, and costing about $2 million. Microsoft asked us to get involved because they were concerned this was kind of going to kill the budget for a project they were working on. And they asked us to design what we thought was necessary to do the IOPS. And we came up with a configuration which was 4 boxes, so 12 rack units, rather than 5 racks of equipment. 3 of the solid state hybrids, and 1 actually just above all hard disk, which are a lot cheaper units. Now what was interesting was that cost about $700,000. So capital expenditure had already gone down. But here was the interesting bit. When they finished it, they said, how much capacity have you got left? Loads. It's not about capacity, it's about IOPS. Okay, we're going to do interesting tests. We're going to keep going beyond 30 million subscribers. And we're going to see at what point you bottleneck. Here's what was interesting. They got to 250 million subscribers before we started to choke. It's 8 times the load for about 1/3 of the cost. Needless to say, Redtent kind of work with us going forward now on projects. But more importantly, Microsoft recognised this because it unlocked business cases. So people who'd previously looked at business cases, whether it be in VDI or SQL or whatever load, had worked out that the numbers just don't stack. Suddenly they're going back and revisiting the projects because we've unlocked it. So a good VDI example is one we actually did with a school district. Now you may think, oh, schools, are they really high I/O users? Schools are the worst type of VDI because they log off and log on loads all the time during the day. So you get nasty log-on storms, you get boot storms, you get crazy things happening in schools. You also get the smart-ass student that tries to do stupid things just to try and annoy the IT department. So these are pretty heavy users. These are about 3,900 pupils across 5 campuses. Hyper-V account using Wise terminals and Cisco switches in the background. And this was a classic example. 40 minutes log-on. In fact, some of their classes were an hour long. So they were 2/3 into the class before they could do anything. Obviously, this was a classic example. But what was interesting on this one is the guy went out and bought his shiny new servers. He bought his nice new Wise terminals and he bought his nice Cisco backend and said, don't worry, I'm going to use the storage I've already got. Because I've got some storage and all storage is the same, so I'm going to use my existing storage. Oops, 40-minute time. Before that, by the way, the reseller had already been saying to him, don't do that, buy some XIO stuff. And he went, no, I don't need it. Surprisingly, the XIO sales guy got a phone call, how quickly can you get here? And more importantly, how quickly can you get us a test box? Okay, they now bring everything up. And what was interesting was the install was up for less than 3 hours. So that morning when they got the phone call and they arrived with the boxes, in 3 hours' time they were up and running with the students logging in a few minutes, if at most. In cases it was in seconds as well. So these guys now love us and a good example of where we've had a dramatic effect. Another one is one in the UK. So it's not just in the US, we've got stuff in the UK as well. And this was actually a heavy Citrix customer. I can't name them because we're not allowed to actually name them, but it's actually a housing association. I'm really evil though, I'm going to point out they're in this room. So if anybody wants to talk to them, we will pull them up on the stand as well. And you can probably tell they are because they're smirking right now. But they have about 7,000 users, about 3,500 IT users. And one of the things that was interesting when we went to meet with them was they actually have some 3PAR, HP 3PAR equipment. So they have some really modern storage. It's not like they were trying to use the cheap, nasty stuff that was in the back of the data center. They're a big HP shop. But actually the business case didn't work out for storage. They needed to go wide, what we call wide stripes, put loads more disks in, and the numbers just didn't stack up. And they couldn't get the IOPS out of the 3PAR or the HP equipment. So they pulled us in. We put in a test box because, you know, they hadn't heard of us, like many of you are probably thinking. So we ran a proof of concept. And actually, the main thing, forget all the numbers, people stopped calling the help desk. And we often hear from people that's a measure. In fact, one of the things the guys have is they always said the first week of January, for some reason, is hell for them. I don't know what it is. Users come back with a health kick after Christmas, start going on diets and think, I'm going to work more efficiently. I don't know what it is, or stop drinking. But actually, they see a peak of workload. And they said, if you can get us through January without that phone ringing too much, then we'll consider that success. That was our measurement of success. And guess what? They got through January. They're now actually increasing the load on it, and they're bringing it in for things like SQL. I recently met some of their SQL team who were dying to get their hands on one of our units just so they could start loading it up. And what they found is it just works. It just sits in the background. As I said, they're in the room, so if anybody does actually want to talk to a real user of our stuff, we can pull them up to the stand and have a chat with them. We just can't name them at this point in time. So what I'm going to do now is hand over to Paul, who's miles away at the back of the room, so we can see how fast he can run, who's going to talk through, as I said, he's going to give a view. The reason I asked Paul to speak is twofold. One is to explain how we do things differently. But second, Paul actually only joined the company 2 weeks ago. Was it 2 weeks? Or was it 3? 4?
It's my 4th week.
God, it feels like shorter. I'm going to ask Paul just to talk a little bit about his first impressions of the company and the technology when he really got hold of it.
Hey, oh, that's better. So I got in there, and the first thing I was expecting was the usual brown box. Because that's what we all get, isn't it? You know, if you go into the storage room in the IT department, it's just full of brown boxes. It might have little logos on it, but you automatically think it's just the same brown box as everybody else. And the thing I found with XIO was they weren't the brown boxes. They were actually decent quality, good thickness, well padded. All the equipment inside the box was there for a good reason, and that was to get it to the end user in one good piece, but to make it look good as well. It doesn't cost much to make a box look good, but it's the thought that goes behind it, because it's quality that we look for. Right? What I want is I want to spend a £5 and I want to get £25 worth of stuff, basically. And that's the first thing I thought when I saw the box was, this looks quite good, this is interesting. When you go into a shop, if you're budget constrained and you go into one of the supermarkets, you pick the own brand chicken. If you've got a bit of cash or you've got friends coming around, you pick the higher level chickens. But you'll only do that if you're pushed or there's a good reason for it. Whereas here, it's just basic. This is what you're going to get. So what I looked for was quality, simplicity, design. It had to be practical. Because if it's not practical, then what's the point? Because it's about reducing admin, not increasing it. It's got to be no gimmicks. So everyone sells gimmicks. You know, if you buy this storage rate, it's great because it's got a light that goes like that. Well, funnily enough, we do have a light that goes like that, but it doesn't anymore. But it's not about the gimmicks, it's about what is the best for us. And the best thing that really did it, the 5 guys that actually lead up XIO are enthusiasts. I was talking to a lady at the back there, another colleague, Karen, and she was telling me about these guys. And they love IT. They've been in it for years, and they love IT. They love what they do. And what they actually did, which I'm going to lead on to, is the technology is totally different technology. It is the next, for me, it's the next big thing. We're taking what we've got and we're doing something different with it. Gavin mentioned that how we use the disc differently. Discs and how they're used have never changed over the years. So if we have a look, just the environment first of all, before I move on to the discs. Simplicity of XIO is the fact of how we manage it. So it's a web interface, and it's basically, you want some storage, there's a host, there you go, how much do you want? Is it RAID 1, is it RAID 5? In virtualized storage, it is actually RAID 1, it's not RAID 10, because theoretically, virtualized storage, you've only got one disk. So the way you chop that up and use it, you wouldn't make a RAID 10, so we call it RAID 1. But this is the interface that you use, and it's really basic. Why do you want anything complex? What you want to do is, you want to go in, give some storage. You want to come back out, get on with your job. Go in, do some storage. If there's any issues, you want it to tell you there's an issue. The other things that XIO does, which I really, really like, is the fact that it sends all the telemetry back to base. So instead of you having a phone home feature, which is really nice, as long as it can phone home. But 9 times out of 10, if your Exchange server's gone down, how's it going to phone home? So we do that permanently, and it's sent directly out to home. So we can track exactly what's going on with the arrays. And anytime there is an issue with the array, we can just pull up the information and go, oh yeah, well, it was tracking like that, trending like that, and we know there's an issue, now we can resolve it. So it's little features that make it different. There is nothing complex in there. If you want to sit there and you want to browse through it, after 10 minutes you'll be bored, because there's nothing else for you to do. So, traditional RAID 10. This is the thing that really sold me, and it took me days to get my head around it. Because traditionally, we like the way that our discs work. Traditionally, we just want to plug a disk in, unplug a disk, move it somewhere. Home PCs, it doesn't matter where you go, it's a disk, you know, you get an advertisement, SSD disk, 120 gig half price, and you go, oh, yeah, that's really good, I'll just swap that and push that in. We make it different, but the reason we make it different is, it's not more complicated, it's just better for you. If we can design something that has 100% utilisation in both performance and capacity, is that not better than having to buy twice as much? So traditional RAID 10, we actually have to buy twice as much storage. And the way it writes is, we get one of that. Bit of data, bit of mirror, bit of data, bit of mirror. And as it writes down what you see over there, does that colour look all right on here? It'll look totally different, the other. Yeah. What you actually see is you end up with 2 distinct stripes, because what we do is we stripe across the disks. Yeah? Traditional storage does that. So, in real terms, what then happens is we've only got half the capacity of those disks because we want the performance. But in real terms, again, we've only got half the I/O of those disks because we can't factor in 100% of those disks because we know that half of it's going to be mirrored data. Now, when we come to read back off it, some vendors will actually give you double reads. So you can read off the top and read off your mirror at the same time. But predominantly, we're jumping from disk to disk to disk, not in a straight line. So we're not getting sequential data. So it moves us along like that. So in reality, our RAID 10 traditional model, it's efficient, it's fast, it's got 100% resiliency, but it's twice as expensive. What the XIO model does is there's no disks on top because we work on a grid basis. So I'll cut down on how the grid put together afterwards because it is quite simple, hopefully. But our model, basically what we do, we can I/O size 100% because when we write data, we use both ends of the disks and the opposing disks. So of our disks, as we write the mirror data to the primary data to the top, we're using the second half of the disks for the mirror. And then we continue to the second half of the disks for our primary data and use the first half of the disks as our mirror. So that again, once we come to read, well, we've still got our full RAID 10. And then when we come to read the data itself, what we've got is nice sequential fast reads across 100% of your RAID 1/10 disks. So we can improve the performance even on a RAID 1. This is all down to these 5 guys because that's what they've thought about for 25 years, how to improve the storage. So if we look at the RAID 5 works normal, it's traditional. So we come along and we start to bounce it in, and then we've got the parity calculation. Then we've got the parity calculation. Then we've got the parity calculation. And RAID 5, you know, the parity calculation is the killer for RAID 5. And we brought new RAID standards out. We've got 50, we've got 60, we've got 6. It doesn't matter which way you dress it up. RAID 5 is not really an efficient way to write data. So when we come to read it, we've got to bounce around the parity again. Now in RAID 10, traditional RAID 10 is great. There are various ways that people will write it, where split disk, 50%, but with a RAID 5, you've still got to bounce over that parity all the time because that's the way it writes it and stripes it to the disks. Again, XIO, we're back to the grid fashion because everything's on the grid. So it doesn't matter whether you're RAID 1 or RAID 5, it's still within that grid. Because we're in a grid, we don't have to stick with 2 bits and then do the parity. So we do with 4. So we do 4 lots of data, and then at the other end, we start writing our parity. So again, we've got full RAID 5, and that's none of them are on separate on the same disk. When we actually come to do the read, funnily enough, it's the same speed as what our RAID 1 is. So just these little simple facts make it easier to make disks and storage faster. And because everything's hardwired in, the disks are now stopping being the bottleneck. Because all we're actually after in storage is moving the bottleneck away from the storage and trying to put the blame on the server manufacturer. So this is helping us do it. So, right, acronym time. XIO uses a thing called RAGS, Resilient Adaptive Grid System. So what we actually do is we chop disks up into little bits and use the bits off disks because it's better. So at the top, we've got WeWorking blocks of 10 disks, and we use 2 disks as spare, or spare space, and the other 8 disks will chop the heads down, and each head has got 2 segments. So we take a segment across the 10 disks, take that away, and we make what we call a book. The book is 1 segment off each drive. So already we're starting to look at how we can place this. We break these up and we build a grid on top of the book. And that grid is broken down again. So inside that we have a sheet. Each sheet we take from 1 drive, and then we've got that. And if you look at the red pieces, what that is, that's our spare capacity from our drives that we're using for spares. So we're actually over-provisioning the drives for extra space to start with. So when it does come to having an issue with the drive and we have to low-level format it, we don't worry about that because we don't have a disk that will fail. We have preventative action. So it sees the disk looks like it's going to fail. It moves the data off into the spare spaces, does a reformat of all the drive, and then puts the data back on. If there's a head that's gone missing, it will evict the head out of the grid, and it will just write the rest of the disk there. So in reality, there's no performance hit on the same scale as what as if you were to lose a disk and do a rebuild. So our sheets, we take a sheet, we move it along, and then that sheet is then again, come on, broken down. And we write another grid in each of the sheets and we create words. And these words are 1 meg bytes, or 1 meg blocks. So we write the data to a word. So each of these sheets has their own sets of words. We take 1 word from each of the drives. And this is where we start to write the data. So we write data to each disk in the 1 meg blocks. 8 of these words make a sentence. So to try and get your head around this first is a bit of a, God, how's all this going? But in reality, we're not actually looking at disks anymore. We're looking at little bits of grid that are overlaid onto the disks, that are then overlaid again and then overlaid again. So the layers are so deep that we can get down to 1 little block. So when CADP kicks in and it sees that your information is, this is hot information, it can move that 1 meg block and not all the file. If you've got a, I don't know, you've got a master in your VDIs, and your master is getting a lot more action than what you anticipated, it will automatically move the bits of the master and not the full master. Sublun tiering and storage tiering will always move the full master around for you, or the full database file around for you. Whereas we can actually move just the individual points of it. So on that, what we're actually left with is XIO for me, and the reason I joined the company, it is quality. If you look at one of our actual enclosures, it's not something that you can buy from China. and change the disk front and make it suitable for Compellent or for NetApp or for Ecologic or EMC. It just isn't. It's a fully designed, shiny box. It actually looks like it's got the quality on it. It's simplicity because, as if you speak to the guys here from the company, it's really simple to manage. It's fire and forget. It does what it says on the tin. The design is even better because the design itself changes to match what we need. A, so that we're in the company, but B, so that you guys can actually use it and it's more efficient for you. I don't care how much it costs. What I care is, does it do what I need it to do? Once I've left your organisation, it's installed and it's working, am I going to get phone calls off you? And if they're not one saying how good the system is, then in reality, I don't want them. So this system ensures I don't get them. And that's me, Gavin.
Do you want to hold on to that in case for Q&A? I'm just going to unclip you. Okay, so hopefully you've got a point that not all storage vendors are exactly the same. There are differences. I just want to point out a couple of things before I finish off, which is some games that get played. And I've got to confess, I've worked for companies that play these games. So it's worth pointing it out. And it's just one thing when you go away, even if you don't come and talk to us and you start designing a storage system for VDI, just things to be aware of. I've seen some storage vendors saying we can handle X number of users per storage grid or per storage array. It's a little bit of a trick because some people actually talk about persistent desktops. Some people talk about non-persistent, so you see all the linked clones games. I've actually seen a storage vendor who I won't name, assuming 8 IOPS per VDI user. Pretty low. You can get some 8 IOPS users. I've seen some users that go with 2 IOPS per user. You know, they do really, really low numbers. We always assume 20. So if you ever see in our marketing figure talking about how many users we can sustain on a single box, we'll always talk about 20 because we think that's a realistic number. You'll see some people that use 100 IOPS per user, some developers and stuff like that. They are out there. But if you go with 20, it's a reasonable base. Another thing is storage footprint. This is one that's common to the solid-state vendors. So the solid-state vendors want it to be small capacities. So they assume 2 gig per VDI user. We assume 20. Now, the truth is they may not need 20 today, but they might do in 12 months' time. Those of you, I'm sure loads of people in this room have bought a home PC or a laptop and said it's got a 250 gig, it's got a 300 gig hard drive or whatever. I'm never going to fill that up. And 12 months later going, oh, bugger. I need an external hard drive because you've filled it up. The truth is Microsoft and various people out there are helping us fill up things, and you think about the digital age and how much is coming around through social networking, there's more stuff being shared. And then simultaneous VDI boots. This is another trick. We like to assume that everyone's going to start up at the same time. The school is the best example. We can't say, right, that class has to start at 9:15 and that class has to start at 9:20. Life's not like that. You've got to assume that you're going to have boot storms, quite frankly, first thing in the morning. And as I said, some places are worse than that. And then tuning parameters. So we've seen this as well, is that it's great when you put the first unit in, but when you add a second shelf, and this is a common phrase that gets used in the storage industry, things start to slow down. And it's not because of the disks, it's because of the controllers. Like I said earlier, you've got to make sure what the controller workload is. We work on a very simple model. If you want to have some more capacity with one of our units, buy another unit, put it on top. You want more, buy another unit, put it on top, and treat it like a grid. The way our management software works is that you just see it as a single entity. You don't have this problem of managing all different boxes, you can manage them as a group. So just watch out for the games that storage vendors play. These are just some examples of ways that people, so go in, ask about IOP counts, ask about bandwidth, if bandwidth matters to you, ask about number of users it can support, and ask about latency as well. So I've seen another one that, you know, an organisation that can do high IOP numbers, but the latency is like 15 milliseconds. That's going to give you problems further down the line. So just think about it when you're sizing it up. Are you sizing by performance? Are you sizing by capacity? The truth is, you probably want to do both. So don't fall into the trap of people talking about just what sort of size capacity you need. I hear lots of people come to me and say, I need 100 terabytes of storage or 10 terabytes of storage. Okay, what type? SAN. Could you be a little bit more specific? Well, I just need some storage. Okay, and the one thing you'll always hear from us, to do what? Now, in some cases, some users are pretty educated and they'll come to us and say, I want a 35 millisecond, sub 2 millisecond latency, 35,000 IOP, sub 2 millisecond latency storage array with a fibre channel 8 gig interface. Oh, right. Pretty switched on. You know what you want. Unfortunately, they're quite rare. Most people come to us and say, I'm rolling out a 5,000 user VDI system with Citrix. Help. And that's where not only internally we have a lot of expertise, but we also have a great partner network that can help us deliver that out there and design that into storage arrays. So just watch out, as I said, that you're very, very careful. This is a common trick, over provisioning, something called short stroking or wide stripes, tricks that are used, which are great. They get the performance up, but they take up a lot of footprint, they put out a lot of heat, they pull a lot of power, and they cost a lot of money, take up a lot of space. So, you know, we're always thinking about that as well, is if you end up with excess capacity, it's going to cost a lot of money and you're just going to have it sitting there and burning a lot of OPEX as well. So watch out for all these tricks in the industry. So, one of the common things I always had been asked in the storage industry is, oh, this is great. How much does it cost? What's your price per terabyte? Be very, very careful in this space. Price per terabyte is not the key metric in VDI. It's price per IOP. Price per gig is important. Don't go and pay stupid money. Don't pay you £20 a gig for storage in the VDI space. But look at price per IOP, price per gigabyte. And actually, this is becoming quite a common one. I get asked this a lot now. Watts per gigabyte. How much power does it take to do all this? Depending on where your data center is, usually someone in Canary Wharf will ask me this question up front. Someone in Bolton doesn't really give a monkeys. So it changes around as to whether that's an important metric for you, but actually increasing it is. A lot of public sector organisations are also worried about, you know, heat output, and they're looking how green a product is. So the fact we only use 700 watts of power to deliver the IOPS we do is a really good thing for us. VDIs and virtual machines provide quite a unique challenge. They're quite one of the worst scenarios a storage designer can see. Can you handle the IOPS, quite frankly? And it's the IOPS that are killing people. As I said, you know, the customer that's in the room has got some really good storage infrastructure. They've done a really good design, actually. Really nice blade chassis. They've designed a great infrastructure to deliver all their users. But it was the IOPS that were killing them. It just couldn't get the grunt out, and that was manifesting itself in terms of desktop freezes. And don't fall into the vendor trap. Think about what you need in 12, 24, 36 months. By the way, a lot of storage vendors will tell you, if you're going to need that much storage in 3 years' time, buy it all now, because you'll be limited about how you lay your data out. It's the old quick fit example. I know you only want your exhaust done, but why don't you buy the tyres at the same time and stuff like that? Don't believe that. I'd love to sell you 5 years storage requirement up front today. Fortunately, the economy is probably going to stop me doing that unless I can do some sort of clever leasing deal. The truth is, make sure you design a modular infrastructure that doesn't take you down a technology cul-de-sac, that you can keep expanding as you need it and fill the units to 100% utilisation. So don't fall for this wide stripe gag of striping it across multiple units. And the important one I keep coming back to is balance. Think about the cost, think about the risk, and think about whether you're going to constrain growth by designing the storage system. It might work today. Is it going to work in 12 months' time? And you'll still be in a job. So, recap. We have an unusual proposition in that we have a linear scale, high-performing, self-healing storage array. And I can't overemphasize this self-healing enough, because self-healing isn't just about availability, by the way. It's also about performance. You might be able to do a RAID rebuild on the hokey-cokey 2000 storage array that you just put in, but what's going to be the effect on performance? And hopefully Paul showed you that we don't have an effect on performance. It's specialised really for virtual infrastructure and databases, but it's really just good at random I/O, at nasty stuff. And by the way, we're very good at sequential I/O, but it's just, we're unusual in that aspect that we can handle random I/O. We have an unmatched price performance. We know our price per IOP and our price per gig are spot on. And you know, people that have looked at us in the marketplace. And the operational economics are good because of the simplicity Paul talked about, and for a number of other elements, the operational numbers work out. And that, unbelievably on time, is it. Are there any questions? We have got a roving mic, which you can't believe the speed that this man can move at. Boys, I'm going to do it. Has anybody got any questions? Come on, someone. You can ask which flavour of donuts are best or anything like that. That's quite a good one. By the way, those who are late in the room, there are donuts on every table. Please eat them. They're going to be gone.
Sorry if I missed it. How is storage presented to a hypervisor?
We just look like a traditional fibre channel LUN. Do you want to cover virtual view at all? Or? Well, okay. So it just looks like a standard LUN. You can either present it through our management interface, so the management interface Paul showed. That's a web-based one, so it's a Java app that's running, so you can attach to it. I know some people love Java, some people hate it. So you can manage it from the box. We have some management software which you can use, which is a Windows application to provision LUNs. Or actually, we have some extensions to ZenCenter and to vSphere as well, called Virtual View, which is an extension of our management software, where you can actually provision directly to the hypervisor as well, which makes life a lot easier. It just cuts down the steps. Some people like to do it, that they provision the LUN, then they put it through the switches, then they slowly build up the stack. Some people just want it that they can just say, give me a LUN, and it connects through. But you just look like a standard fibre channel LUN to the infrastructure.
Just on top of Virtual View, when you actually use it, if you're using VMware or Zen, and you want to provision a new LUN, you've got to go to each host, and after you've created the data store, you've then got to scan it back in and set your multipathing, etc., on each host. With Virtual View, because it interfaces to both sides, you just say, I want X amount of LUNs, I want these servers to see them, and I want it this big, and whatever the actual format that you want, set, go, walk away, and it will actually do all the work for you, again, reducing the admin.
Anything else? Sorry, did that answer your question? Okay. Good. Right at the back, that always happens. It's back to front, it always does.
There's a company releasing a new product tomorrow, which I think you mentioned. Can I mention the name?
Yeah, go.
Nutanix, is it?
Who, sorry?
Nutanix?
Don't know.
Nutanix.
Oh, Nutanix, right. Yeah, sorry, yeah.
How does your product compare to them?
Don't know enough to answer that question sensibly. Do you? You come across it? No, I don't know. I'm not going to jump in and say how we compare to vendors. The truth is, there's a lot of different approaches in the marketplace that try different things. I don't know these guys face to face. I know the name. I've come across them. I try not to get into vendor versus vendor bashing. I try to talk about different approaches. We're seeing a lot of people starting to talk about the hybrid marketplace. I think the difference we have, without knowing that, and I'm assuming they sort of play in a similar space, is that we've been around for a long time. The fact that we've been around for 17 years, these guys have been designing storage arrays for 25 years and have kind of learned all the weird stuff and things that can go wrong. Stands us in good stead. The support network, the way our support system works. If you get a chance to talk to the customer that's in the room, they had a very, very unusual thing. They had a hardware failure. I'm going to be open here. The reason they had a hardware failure is somebody inserted the controller and bent a pin. So somebody pushed the controller in, bent a pin up. This is one of those weird, remember I said about humans cause the problems, not computers? This was somebody pushed it in and must have felt resilience, and it bent a pin. It didn't manifest itself until the box went under load. They had to call in our support team. We just, without hesitation, swapped the box, changed a lot of thing out. They got a lot of love and a care about it. And they actually said to us, we dealt with so many different storage vendors across the years. We have never seen support like that. We then followed up with a root cause analysis that showed exactly what it was. We showed we've made a change in our firmware that even with a bent pin, which is the weirdest thing in the world, we can actually still recover from it and everything like that. So we made changes. And they actually said, we've never seen support like it, the care we got, the root cause analysis, these things happen, it's the way you do it. We couldn't do that if we hadn't learned a lot over the last 17 years and have got that infrastructure in place in Europe right now. There's a lot of good startups out there, but they just haven't got the infrastructure and the experience that I think our guys have got. Any more? Sorry, one in the middle. We're going to keep this. Go on, yep.
I get it. Just a quick question. You made a comment earlier about SSD being a saviour.
Yeah.
Now, everybody knows that SSD tends to degrade after you get full.
Yep.
How do you get around that?
Good. So, a lot of the things we do with disk about avoiding places, actually the same applies to solid state. So if you do get cell burnout and you do get write cliffs and stuff like that, it's actually the same logic. You can avoid that area. Now what we actually do is we put all our writes into cache first of all. So actually the way we're writing to the solid state or the way we're writing to the hard disk is bearing in mind a lot of the problems that you can have that. So one of the ways we can do it is the way we lay the data out is controlled by us at the back end because we're writing to cache and then destaging the cache. If you want, you can set it to write through, where you write directly to disk. We try to avoid that because writing to cache is always going to be better, especially with sequential workloads. The worst thing you ever want to do is write that to an SSD. I've actually seen SSDs be slower than hard disk on a sequential write. But then the second thing to do is if you do get cell burnout, avoid it. So, you know, I talked about our boxes being 10 terabyte usable. We're actually our hyperbox, so our hybrid of solid state and hard disk, we talk about 14.4 terabytes, what you would probably consider raw. To us, we call it pre-RAID. The truth is we don't sell raw storage. So there's a lot of, most vendors out there sell you a raw capacity and a usable capacity. So they give you two figures. We don't. We give you pre-RAID, post-RAID. Now within a 14.4 terabyte pre-RAID box is actually, I'll tell you a secret, about 22 terabytes of storage. But we over-provision a great deal to handle failures. We believe that any failures in the hardware are our problem, not yours. Why are you paying for something you can't actually use? And I've actually seen some extremes. I've seen some vendors that will sell you a 20 terabyte disk array and it's 6 terabyte usable because you took off hot spares, you took off all these bits and bobs. We don't do any of that games. We just give you, if you want to do RAID 1 on a 14.4 terabyte box, guess what? You get 7.2. And then the spares. And we actually over-provision the solid state by about 50%. Huge amount of over-provision. Because we're paranoid that in 7 years' time, you will have cell burnout. So we over-provision it deliberately. Truth is, we're finding out we probably overcooked that a little bit. It's costing us some money. But we do it in two ways. So one is over-provision. The second thing is work around the cell that's burned out. Because it's going to happen, but you just got to work around it.
Is that risky? Power failure, if you cache it?
Great question. That's why there's big, big, big supercapacitors in the front, which you should never stick your finger in because they kind of hurt. We have enough charge there to hold up the power to destage the RAM into there. So you're right, working with volatile memory can be dangerous. You've got to make sure that the tools are in there. So if the power is yanked from the back, from both sides, then actually we destage firm. Even if the power is lost and isn't restored, we can actually hold the charge in those supercapacitors for some time. But the truth is we destage to the solid state.
What about snapshotting and replication to something like DRC?
So, there's an argument going around in the storage industry, and it'll be interesting to hear the views of the room on this one, that things like snapshots, dedupe, advanced features like that, and moving around data, is actually not best performed by the storage array. It's best performed by the hypervisor or by the application. So go and talk to Microsoft. Microsoft will tell you use dumb as storage, okay? Don't use any intelligent features. Use things like always on in SQL Server, use their features. Go and talk to VMware. With the exception of replication, they'll tell you to do everything at the VMware layer. Now, the truth is life's not that simple. We like to think that's where the market is going, and we are aiming for what we call, the US call it frame free. I don't like the argument because we don't use the term frame here. But what they mean is get away from the big storage vendors with the big intelligence at that layer. We see that intelligence moving. But we've had to do some gaps in between. So number one we do is we have the ability to do synchronous replication, but with a twist. So we kind of, you probably gather, we like to do things a bit quirky and a bit different. We could do synchronous replication like everybody else does. You have one live, one passive, and you replicate between the two. We're a bit cranky. We have active-active. So you can have two arrays on two different sites, both serving reads and writes. And then we handle the mechanism in between, the locking mechanism, to avoid split brain, which is the worst ever scenario you want in a synchronous replication. But we can actually deliver active-active. And that's something we're just in the process of bringing to market now. So we have replication. Snapshots are an interesting one. Most people are doing snapshots at a higher layer now. We actually are going to be doing snapshots, I'll tell you a secret, within our box soon. And the only reason for that is one reason only. Site Recovery Manager. VMware Site Recovery Manager uses snapshots. We didn't want to do it. We did it because of that reason. So actually, we're just about to bring snapshots to marketplace. But actually, I see that intelligence moving up the stack. I see the applications, the operating systems, and the hypervisors taking control of intelligence. There's a reason EMC went and bought a shed load of software companies, because they saw the intelligence moving out of the array and into different layers. They saw it coming, and it's the same way we think at the moment. So that's about the one time you'll hear me be nice about EMC. It doesn't happen very often. Anything else? I think we're out of time anyway, aren't we?
Yeah, round of applause for Gavin, please.
That's the prompting. Thank you. And please pop by our stand later on, and please make sure you get scans so you won't get a chance of winning the iPad.
We're breaking for lunch now. There's also the